All right, everybody, welcome back. Yesterday we talked about simplifying complex numbers. We talked about adding, we talked about subtracting, and we also talked about multiplying. So today we're going to work on conjugates for both complex and radicals, and we will also get into a little bit of division. So remember, big important things you need to know. The biggest carryover from yesterday is that I squared is equal to -1. That is the biggest carryover that you cannot forget. All right. That'll come into play later. I just wanted to carry that over at the beginning. So first of all, let's look at complex conjugates. So if you have a general form A plus BI, that is your general complex number. A is your real part. BI is your imaginary part because it's got the I. Your complex conjugate is always going to be A minus BI. You just change the sign of the imaginary section, the imaginary piece. The real spot, the real piece stays the same. All right, so if we're looking at these really quick, 3 minus 5i, the complex conjugate of that is going to be 3 plus 5i. 7 plus 2i, the complex conjugate is going to be 7 minus 2i. For C, the complex conjugate for 6i is -6i. There is no real spot, so it's okay. This one's written backwards. Don't let it fool you. You're going to have 4 plus 3i. If you want to rewrite that as 4 minus 3i, if you switch them, the complex conjugate is going to switch the imaginary spot. So now I'm going to multiply the complex number and its conjugate so you can see what happens. This will get us a good multiplying practice. This is, once again, coming into play with the I squared equals -1. So the complex conjugate of 3 minus 5i is 3 plus 5i. So now I'm going to FOIL. So 3 times 3 is 9. Outside plus 15i, inside minus 15i. Last, you get a minus 25i squared. The complex conjugate, the nice thing, this should always cancel out. -25i squared becomes a plus 25. So your answer here is just 34. Let's look at B. So I have 7 plus 2i. So I'm going to multiply that by the conjugate, which is 7 minus 2i. So now when I FOIL it, you got 49 minus 14i plus 14i minus 4i squared. Those cancel. That becomes a positive 4 because you got -4 times -1. And then 49 plus 4 is 53. Let's look at C. You should start to see an emerging pattern. So minus 6i. So I got -36i squared. But remember, I squared is equal to -1. So -36 times -1 is positive 36. Rewrite this, so 4 minus 3i. I'll cross that out now. I'm going to multiply it by the conjugate, so 4 plus 3i. So first, outside, inside, last. And you start to see something nice. That becomes a plus 9. You're changing the sign, so 16 plus 9 is 25. All right, if I zoom out, look at those 4 answers. What do you notice? Pause for dramatic effect. All of them are just real numbers. They're positive or negative depending on what it is. All these happen to be positive, which is nice because my A's were all positive. So the conjugate, when you multiply by the conjugate, you are able to cancel out the imaginary unit. So there is no more I. All right. With radical conjugates, it's the same thing as above, except for there is not an imaginary part. But we still have a radical. The radical sign changes for the conjugate. So here, instead of 1 plus square root of 2, oh, wow, that was just real bad. I get 1 minus the square root of 2. That's my conjugate, my radical conjugate. Instead of square root of 5, it's negative square root of 5. Same thing here. If you rewrite it, -1 plus square root of 3, conjugate's going to be -1 minus the square root of 3. So remember, your conjugate's just changing the sign of the imaginary part for complex and the radical part for radicals. So the question is, why do we need to know this? The whole purpose of conjugate is it allows us to divide complex numbers. We can never leave a radical or an I in the denominator. It's not legal in math. So you'll also hear me call this as rationalizing the denominator, so on and so forth. So if I walk through a few of these. With this, just go ahead and train yourself. So we're going to multiply by negative 8i over negative 8i, because the conjugate of the denominator is 8i, so the conjugate is negative 8i. So now once I got this, I'm going to multiply straight across. So 3 times negative 8 is negative 24i. 7 times negative 8 is minus 56i squared. 8 times 7 is 56. I'm going to divide that by 8 times 8 is negative 64i squared. Now I'm going to simplify. Remember, I squared is equal to negative 1, so that becomes a positive 64. That becomes a positive 56. So I got 56 minus 24i over 64. And then we always want to reduce. So if I'm looking 64, 24, 56, they are all divisible by something, at least 2. I think they're all divisible by 4. So if I reduce them by 4, divide everything by 4, you get 14 minus 6i over 64 divided by 4. That one is 16. So I still look at this. I can still see they're all divisible by 2 again. So let's do it again. 7 minus 3i over 8. And we got our final solution simplified. All right, let's jump over here to B. It's a little bit trickier. So I got 5 plus I over 2 minus 4i. I'm only looking at the denominator, so I'm going to multiply this by 2 plus 4i. And then what you do to the top, you got to do to the bottom. So the complex conjugate of the denominator. So now, I'm going to FOIL the top, FOIL the bottom. So if I FOIL the top, I got 10. So first, outside, so plus 24i inside. And then last, over the bottom, so I got first is 4, outsides, insides, so outside, inside, last is negative 16i squared. Now let's simplify. So that becomes a minus 4. If I add those together, that's a 26i. Those cancel. This becomes a plus 16. So now when I simplify, I got 10 minus 4 up top, which is 6, plus a 26i, because I combine those. 4 plus 16 is 20. Now I want to reduce. They're all divisible by 2. So 3 plus 13i over 10. And I'm okay if you leave the answer like this. If you want to split it up, some people do this. To me, it doesn't matter. Those mean the exact same thing. I can't leave that because it was a smile or a frowny face going the other way. So we'll leave it like this. All right, let's look at a couple more. So 3 plus 8i divided by negative I. So I'm going to multiply this one by I over I. What you do to the bottom, you do to the top. So distribute that. So 3i plus 8i squared over negative I squared. Simplify. That becomes a minus 8. That becomes a positive 1. So 3i minus 8 over 1. That just reduces to negative 8 plus 3i. Write it in order and you are good to go. All right, last division one we're going to talk about. So 2 minus I, the conjugate is 2 plus I. All right, let's FOIL the top, FOIL the bottom. So I got 6 plus 3i minus 2i minus I squared. 4 plus 2i minus 2i minus I squared. Let's simplify. That becomes a positive 1. If I add those together, 3 minus 2 is 1, so I just got an I. Those cancel. That becomes a positive 1. So 6 plus 1 is 7. I just have an I over 5. And that's my final solution there. Cool. All right, so that's your division. So division, we are going to multiply the top and the bottom by the complex conjugate. That's called rationalizing the denominator. That's how we divide fractions with i's. Now dividing radicals is the exact same way. You're just going to rationalize the denominator. It's a little bit trickier, but don't let it freak you out. So I'm going to multiply this by 1 plus the square root of 2 over 1 plus the square root of 2. All right. So let's distribute the 5. So 5 times 1 is 5. 5 times the square root of 2 is just 5 square roots of 2. You just smash them together. At the bottom, you got 1 plus 1 square root of 2 minus 1 times square root of 2 minus the square root of 2 times 2 is 4. So I know those cancel. I know the square root of 4 is 2. So I'm just going to have minus 2. So I got 5 plus 5 square roots of 2 over negative 1. With this one, I can divide everything by the negative. So my final answer here is negative 5 minus 5. No i's here. I'm working with square roots. I just did a bunch of those, so I'm brainwashed. So negative 5 minus 5 square roots of 2. That's going to be my solution. This allows me to get the square root out of the denominator. All right. This one's a little tricky. I like to simplify what I can here. So before I start doing this, I see I have a square root up top, square root up bottom. So remember your rules. You can simplify it. So this is 7. 7 times the square root of 1/4. So remember 7 times the square root of 1 over the square root of 4. If I simplify that. So the square root of 1 is 1. Square root of 4 is 2, and you are actually done. You don't have to rationalize this because it's simplified using your rules we learned last week. All right, last one. I'm going to multiply this one by negative 5 minus the square root of 7. Negative 5 minus the square root of 7, because that is my conjugate. So let's distribute the top. So negative 3 times negative 5 is 15. Negative 3 times negative 7 is positive 3 square roots of 7. Negative 5 times negative 5 is 25. Then I have a positive 5 square roots of 7. Then I have a negative 5 square roots of 7. That's a 7, not a 5. And then I have a minus square root of 49. So when I start simplifying here, those are always going to cancel. That's the conjugate. Square root of 49 is 7. So that becomes a minus 7. So I have 15 plus 3 square roots of 7 up top. I can't combine those because those are different. 25 minus 7. It's a wonderful number, is 18. Now, if I'm going to simplify, I'm going to look at the coefficients and the real numbers. I'm not looking at the radical. It's just tagging along. All of those are divisible by 3. So my final answer here is going to be 5 plus the square root of 7. That 3 cancels out. 18 divided by 3 is 6. And you can leave it like that, or once again, if you want to split it up, or just so you see options, 5 over 6 plus the square root of 7 over 6. Those, once again, are the exact same. Cool. So a big thing, make sure we are rationalizing. We're getting the proper conjugates. And that is what we're doing today. So good luck. Work through your practice. If you got questions, let me know. Hope you have a wonderful rest of the day.